Hey guys, welcome back. We're about to get on to a new unit. We are going to start a biomolecules unit. This is going to help you get ready for your biology course next year. So, when we first came back from spring break, we did bonding, single, double, triple. Then we went on to counting atoms. So remember, single bond is sharing two electrons between two atoms. So hydrogen sharing two electrons with oxygen. Then we moved on to double bonds, sharing four electrons or two pairs of electrons between atoms. Then we went to triple bonds, the sharing of three pairs of electrons, so a total of six electrons between atoms. And then we went on to counting atoms, and then we went on to being able to balance an equation. We also talked about covalent and ionic. So covalent is the sharing of electrons between two nonmetals or two elements that are close to each other on the periodic table that act very similar to each other. In our class, we just did a blanketed as two nonmetals. Then we talked about ionic, which is a metal and a nonmetal. In our course right now, that's how we defined ionic. The transfer of electrons from a metal to a nonmetal, creating oppositely charged ions. A cation, which turned to positive because it gave up electrons. And then we went to anion, which took electrons, so it became negative. This is leading us into being able to discuss and identify our four biomolecules. That's going to help you with the first several weeks of your biology course. So let's get started. So as you can see, here is my paper. Our topic today is biomolecules. This is our first section. We're only going to cover two of the four in this video. Then we're going to cover the last two in the second video. Our essential question, it's just a topic question, is we are going to be able to identify the structure of the four biomolecules that contribute to everyday life. Without these biomolecules, we would not be able to live and survive. Life on Earth would not exist without these four basic molecules. Okay, so just like the last couple of note session, we're going to define a couple of terms, then we're going to get into the meat of this note session. So our first term is biomolecules. If we go to break this term down into two sections, we can look at the term bio. All bio means is life. Like biology, ology means the study of life. Here, biomolecules, we have bio, which means life, and molecules is basically simple give life. So it's the molecules that give us life. For us, the way we are going to define this term is the four basic molecules needed for life to exist. Get that glare off. So biomolecules is the four basic molecules needed for life to exist. So the four basic ones that we are going to talk about today. Jenna, find me a black pen. Here we go. The four that we're going to talk about today are carbohydrate, lipids, protein, and nucleic acid. In this video, we're talking about carbohydrates and lipids. And in the next video, we are going to talk about our nucleic acids and our proteins. So this is that's a C. So today, in this video, video 1 for biomolecules, we're going to talk about carbohydrate and lipid. The next video is protein and nucleic acids. So our next term we are going to identify is monomers. So all we can think of is mono, not like mononucleosis, not the throat illness or the and everything. I just realized that was very late. So mono, that suffix mono means single. Monomer means single molecule or single piece. So mer, you can say piece. So a single piece, when we build these single pieces up, we make a biomolecule. So several of these monomers will bond together to make a biomolecule. So we can think of our monomers as the building blocks of our biomolecules. So these are basically our Legos in our body. If you've ever played with Legos or Lego logs, you take one at a time and you can build your structure. I realized that is way, that I don't like that color. Like Legos. So I'm going to show you an example. We're going to use these little fluffy balls, okay? I have all of these little fluffy balls. Each one of these, if we separate them out, are considered our monomers. This is a monomer. This is a monomer. So we have, I'm going to narrow it down to, say, 6, 8, 10. I have 10 little fluffy balls. If we spread them out, we can say we have 10 monomers. I have 10 monomers on my paper. So each one of these is a monomer. We can take each one of these monomers, and I'm going to have my little glue bottle. I'm going to do some arts and crap right now and pretend this is a monomer. I'm using the glue as a bond. So, and then I bond 2 monomers together. I'm starting my biomolecule. So monomer, 2 monomers bonded together. And then I do another. It bonds together. Now I have 3 monomers bonded together to build my molecule, my biomolecule, my molecule for life. And I can keep adding these, keep bonding these together. And my biomolecule gets bigger and bigger and bigger. Now for the biomolecules that we're talking about today, but carbohydrates, lipids, proteins, and nucleic acids, each one of these monomers are going to change their names depending on the biomolecule we are talking about. So if I go carbohydrates, it'll have one name. and then I go, psh, boom, lipids. It's going to have a different name for those monomers. Proteins, and the name changes again. The structure is going to change for each one of these. So now we're going to get started. So remember, a monomer is a single piece, one piece. And we start building these monomers on top of each other to make our biomolecule. Okay, move my arts and crafts stuff over away. Now we're really going to hit the meat of our topic today. We are going to start with carbohydrates. Okay, carbohydrates. This is the stuff that we eat that people say make you fat if you eat it. If you eat too much of it, if you don't eat enough of it, you're going to be sluggish if you don't eat it because you're not going to have the energy. Carbohydrates. Okay. Carbohydrates give us the energy we need to be able to move. It's a quick source of energy that we'll eat, burn through, and need a replenishment of it on a regular basis. Okay, so carbohydrates. Now we're going to go and give carbohydrates a definition. This is a food source which is made up of an organic sugar compound. Now, one thing I want to make clear, this term organic, we have been hearing this word over and over and over. Eat organic, eat organic. This is organic. All organic means in chemistry is that whatever you were talking about is made up of carbons and hydrogens mainly. The big component of that molecule is carbon and hydrogen. That's all that means. So for us, you, me, your mom, your dad, your aunt, your uncle, we are all organic species because our cells, our entire body is mainly made up of carbons and hydrogens. So what I want you to do is make sure you note organic equals carbon and hydrogens. That has to be present to be considered organic in chemistry. Will that be on your test? No, but I want that in the back of your mind because it's going to help you out. So with that being said, the carbohydrates that we eat, they all have carbons, hydrogens, and this is an and, very few oxygens. I'm going to bring this down so you can see a bit better. So they all have carbon, hydrogens with very few oxygens. Your base, I'm going to come down here further in just a bit, and we're going to draw it out. I want you to know a carbohydrate is a food source. It is a sugar compound. So no matter if you are eating a tomato, if you're eating a sweet potato, bread, those are carbohydrates. Those are basically a sugar. So now that we're going to go further down, we're going to go to the function of our carbohydrates. Carbohydrates provide us a quick source of energy. So they provide us a quick energy source. Why we say this is quick is because we burn through it very, very fast. This does not stay in our body very long. Our bodies will break it down and use it as fast as we need it. But if you eat too much of it, yes, it can build up and be stored as fat and you can gain weight. That has been a couple of questions I received in class. But that goes into a whole nother thing of caloric intake, which we are not covering today. So some examples for a carbohydrate are potatoes, pasta, rice, uh, sugary cereals or any type of cereal. So your Pop Tarts, your Pop Tarts, your breakfast cereals, those are all carbohydrates. Some of them do have proteins and fats in it, but majority of it is carbohydrates. Our wonderful fruit, our blueberries, watermelon, kiwi, many veggies, even though they have other benefits for us, other micronutrients. Our veggies contain what we call a macronutrient or a biomolecule of carbohydrates. So potatoes, oats, so we have pasta, rice. Remember, corn is a high starchy veggie. So even uh, so those are some of the examples that you will see on your test. So now that we're going to go, we've gotten our examples, we've gotten what the function is, provides us a quick source of energy that we can use. That's why if you're an athlete or if you like to run or work out, you'll eat a banana before you work out or something to give you a quick boost of energy so you can keep going. Or if you like to bike ride, my husband is a cyclist. He likes to take these little carbohydrate squeezy pouches while he's on a long bike ride for like an hour and a half, 2 hours. He'll take one of those real quick to give him a quick burst of energy. So now we're going to go and do the basic structure and what the monomer for a carbohydrate, what the name of that one is. So for carbohydrate monomer, so monomer is a monosaccharide. So saccharide is the monomer for a carbohydrate. You can see this shape, a monosaccharide, in one of two ways. I cannot draw to save my life if y'all have not realized that yet this year. So I've got me a little template. It can be a pentagon or it can be a hexagon as a monomer. So remember, mono is one, so one. So you have a pentagon. Oh, I should have just done that. Or hexagon. And when you bond these together, you make a bigger and bigger chain. I'm trying to find me a nice little, I don't have a pencil. Gosh darn it. So what I'm going to do is I'm going to show you a way. So I'm going to take it over here. I'm going to draw a little bit of a bonding situation going on. So if I bond, so there's one hexagon. I can take my bond and it bonds to a second Okay. Now my monosaccharide has turned into disaccharide, or my biomolecule is getting bigger and bigger and bigger. So remember, monomer only means one, because mono means one, monosaccharide, one sugar molecule. That's all monosaccharide means, is one sugar molecule. We go down here, disaccharide means two monosaccharides. Bonded together. And all monosaccharide means is sugar molecule. So two sugar molecules bonded together makes a disaccharide. Trisaccharide is three monosaccharides. And poly, this is where we just start going, I'm done coming up with suffixes or prefixes, excuse me. So I'm just going to just be general. Four or more monosaccharides bonded. So, right now. So one monosaccharide here, bond it, makes di. If I were to add a third, it'd be tri. Add a fourth, it'd be poly. We'd start considering it a poly. Now we're going to go ahead and move on. If I can find my other note sheet. There it is. Woohoo. Now we're going to move on to lipids. So lipids is what makes everything taste so yummy. This makes everything taste so yummy, so delicious, and is very, very addictive. Lipids are just our basic fats. Again, these are organic compounds that are mainly composed of carbons and hydrogens. Remember, organic, all that means is it's considered mainly carbons and hydrogens. For a lipid, so carbon and hydrogens mainly. Fats have carbons, hydrogens, with a few oxygens. Fats, if you've ever made your own salad dressing, or if you've gone and mixed up water and oil, like your vegetable oil or whatever, you know lipids are not soluble in water. They do not dissolve in water. If you've ever gotten like cooking grease or Crisco or car grease or oil on your hands, and you go to the sink and you try to wash it off in the sink, it's not going to wash off. You need to use a soap type of product to be able to wash that off. So we know lipids or are fats not soluble in water. So they do not dissolve in water. So I'm going to give you some examples of a lipid here in just a minute. Actually, I'm going to do so right now, and then we'll write them out. So some examples of lipids are lard, oils, so vegetable oil, canola oil, avocado oil. You have cream cheese, butter, the yolks of eggs, not the egg whites, not the clear runny stuff of the egg or the white when you cook it. It's the yellow part, the egg yolk. That is where all the fat lives. And nuts. Nuts do have a little bit of protein, which we're going to cover next, but they are mainly a fat source, especially almonds and walnuts. So, so the function of a lipid is they provide us a long source of energy. So they give us energy that sustains us for longer periods of time. So if you eat like a heavy fat breakfast, say you eat scrambled eggs, and you eat a ham steak or bacon, and you eat a little bit of fruit, you're going to be satiated a little bit longer than if you were to eat that fruit by itself, because you have a little bit of fat that's going to take your body longer to break down and to digest, which will keep you going a little bit longer. That's why they tell you if you're eating a Pop-Tart, you'll eat that Pop-Tart and then you'll be good for about an hour or two, and then you're starving again and you're sluggish, you're tired because you burnt through all of that carbs of that Pop-Tart and you had no fat to be able to sustain you. So we need that fat. And here's a fun fact. Your brain is mainly composed of fats. So without that fat, your brain starts to get sluggish and not think because it doesn't have what it needs to be able to keep going. So it's a longer source of energy, an insulator. So for us, a little bit heavier individuals, if you have a friend that is a little bit thinner, or you have that's not as heavy as you, or for you skinny people, if you have a heavier friend that constantly says, I'm hot, I'm burning up, they're in a t-shirt and shorts and you're in the same clothes for your like you and your skinny friends or whatever. You say if you're a hefty person, you're wearing a short and a t-shirt, your skinny stick figure friend is in the same outfit. You're still burning up, not doing anything. You're still sitting on the floor. Your friend goes, I'm freezing. The heavier individuals have a little bit more fat on them to be able to keep that heat in. So they have that insulator to keep body heat in. That's why they say for newborns or for infants to keep them wrapped up, because infants don't have a whole lot of body fat on them to keep them warm. Lipids also form the membranes of our cells, excuse me. So if you've ever, I'm going to bring a cell. We have a cell, if you've ever seen a cell, inside that cell you have the nucleus, the mitochondria, other organelles within that cell. On the outside of that cell that surrounds all of your innards inside that cell, the outside of it is made up of lipids to hold everything in and protect it. So again, some of your examples for a lipid are oils, butter, avocados. Avocados are all pretty much fat, bacon fat, or the white strip of fat that's on your steaks, meats. So egg yolks are all fat. Nuts are mainly fats. Cream cheese and many types of dairies. So your whole milks, your whole milk cheeses, those are all fats. They have a little bit of protein, a little bit of carbohydrates, but a lot of it is a fat. Ooh, buttermilk. Buttermilk is mainly fat. So that's a lipid. Now we're going to talk about the structure of a lipid. There's two pieces to a lipid. Some people think of it as a monomer. Some do not, because monomer, like I said, mono means one, but this monomer composes two different pieces. So the structure of a lipid composes two pieces. A glycerol backbone is one part. So two pieces compose a lipid. The lipid monomer, the two pieces are called a glycerol backbone and fatty acid tails. And I'm going to draw it here in just a second. So I'm trying to look for a darker color. So the two parts. So this is one part. That's two parts. Here, the first part, glycerol backbone, we're just doing the basic structure. Later in the next week, we're going to learn the functional groups, what makes this up exactly, and how it looks. So glycerol backbone. And three fatty acid tails. That's a T-A-L-S, tails. So three fatty acid tails, 1, 2, 3, attached to a glycerol backbone. So glycerol. So this is what we call the monomer for a lipid. Glycerol backbone with three fatty acid tails. So now we're going to move on. And like I said, some examples of a lipid. Now we're moving on to saturated and unsaturated, these terms. All saturated means is only single bonds are present. All carbons have max number of hydrogens it can hold. So I'm going to draw another example up here at the top. Let me get another color for a second. Let me do this. Okay. I'm going to draw another example right off to the side and give you an example of what all three of these look like. So that's my glycerol backbone. This is an unsaturated fatty acid too. So when I draw this, in chemistry, we are efficient with our time. I don't draw all these carbons because everything is made of carbon in our body. It has some type of carbon. So what we can say is every single point is a carbon. And these are our single bonds to these carbons. So that's a single bond, that's a single bond, single bond, single bond, all the way down. This carbon has two hydrogens. This carbon has a hydrogen and a hydrogen, okay? This carbon on the very end, because he has nothing else attached to him on your right-hand side, has three hydrogens. This is what we say is a saturated fat. Every carbon has the max number of hydrogens it can hold. Because this carbon here, the very first one onto my glycerol backbone, is singly bonded to my glycerol backbone and bonded to this one carbon to its right. It has two hydrogens because it needs 4 bonds. So he now is full, he's happy. Same thing with the rest of them. So a saturated fat means only single bonds are present. All carbons have the max number of hydrogens they can hold. Now, if we go to identify unsaturated, unsaturated means at least one double bond is present. With a minimum of 2 hydrogens missing. So here's an example. Get another color real quick. I'm going to do pink since I haven't done pink in a bit. So I'm going to draw another tail. But this time I'm going to show you what an unsaturated fatty acid looks like. So if you notice, this one already looks a little bit different. Carbon here, here, here. This one already looks a little bit different. The second one looks different than the first one. As if you notice, the fourth, 1, 2, 3, 4, and the fifth carbon from the glycerol backbone are in a straight line. He has 1 hydrogen, he has 1 hydrogen, and there's a double bond. So because each of these carbons are missing 1 hydrogen, they each have 1 electron left. They can take those electrons and go, hey, bud, let's share them and make a double bond. So then they double bond to each other, and this is what we call unsaturated because they do not have the max number of hydrogens they can hold. If they break this bond, then they can gain those hydrogens back, and then it'd be considered a saturated fat. So a polyunsaturated fat means 2 or more double bonds are present with a minimum of 4 hydrogens missing. And this would look very similar to this right here. So I have a carbon here, here. there would be a double bond. I'm trying to find my red. Double bond here, here, here. He has 2 hydrogens. This N one has 2 hydrogens instead of the 3 because he's now double bonded to the carbon on his left. He has 1 hydrogen. He has 1 hydrogen. Hydrogen, 1 hydrogen. So each carbon is missing a hydrogen that is bonded to another carbon that is missing a hydrogen. So this is what we call a polyunsaturated because there's 3 bonds, so we meet our minimum of 2, and it's missing 1, 2, 3, 4, 5. Oh, and I forgot he is missing a hydrogen right here. He's missing a hydrogen, so we're missing 6 hydrogens total. So that is our polyunsaturated. So we covered carbohydrates and we covered lipids in this video. Carbohydrates, trying to find my page again. The monomer is a monosaccharide. 2 monosaccharides together make a disaccharide. Trisaccharide is 3. Poly is 4. Carbohydrates give us a quick source of energy. We know monomers when we take 1 monomer and we bond it to a second, we can start creating a biomolecule. The 4 basic biomolecules are carbohydrate, lipid, protein, and nucleic acid. So go to the second video and learn about our proteins and nucleic acids.